Yeah, hallelujah. So we're still in Easter for 3 more weeks. Oh, there's a forest. All right, so let's see here if you can do it, Jason. So I don't know if Ray is here. Rayleigh is here. Okay, so everyone seems to be here. Okay, so I'll next time. Yeah. So for as I said here, like just wait until I send this email, guys. Okay, do not attempt to um, ask to be invited, ask to be admitted until I send this email. Okay, guys. So questions. Questions. You did them all. No problem, Matt. Whoops, who's this? Oh, what does it say? People here. Madav, yes. Oops.
Sure. I had when I was going back over my work, oftentimes if I added up the total resistance wrong, it led to a lot of errors.
You
If
mean when you
we
do like when you did decimal? Or you did
35,
you did no. Well, you did decimal or you did fraction.
I used fractions.
It should be like of course the book like used decimal, right? So it should be like a little. It should be like not that way off though.
It
I'm
wasn't
not so sure.
it wasn't too much off, like say
Yeah,
2 off, but I think 2 off like means I added up parallel circuits wrong or something.
it might. That's why I asked like people to use fraction here because that's for sure you're not going to sort of make mistakes as you go along. I mean, the error is not going to be carried along. Um,
Yeah, so I wanted to ask if we did this on a test and we got like one of the calculations wrong and then it messed up
well,
all
as
the
long,
others.
yeah, you're not. I'm not going to dock you for everything else that happened after, right? Because it's all
Okay,
based on yeah.
thank
Okay,
you.
but is there a problem you want me to do or what?
I just wanted to know. I'm sure like it's just me making math errors, so it's not
Okay, maybe
important.
not. Okay, so Max, can I type it? Okay, all right, you can type it. You can type it. Oh, my computer is starting to. Really, it's the same password. What is this? This is stupid here. I have to sort of change the password. Well, I'll be able to change the password. Okay, so hold on a second. Yeah, okay, yeah, or call with someone. Yeah, so like, all right, like, was it? I don't know where you. Okay, Forrest, you won't be able to speak. Sure. Okay, I'm not so sure if the diagram was it electron. You mean where, Max? You mean diagrams in a textbook? Diagram in textbook is pretty bad. They might sort of show the electron flow instead of current. So Max, which because it moved from yeah the textbook like show the electron flow, not the current. Yeah. Uh, 35E. Okay, so 35E. All right. Okay. Anyone else here? So 35E. So I'll do E. Anyone? If Mr. Lizik, if you schedule a meeting for your Zoom account instead of your personal, it will change password and leagues. Oh, from your Zoom account. I have my Zoom account instead of using the personal meeting. So what I'm doing here, I'm using my personal meeting room. Madav?
Yeah, so you can schedule like new calls every time you wanted to do a new one, or you can use your personal meeting room, which has the same.
Oh, I see. Okay, I'll figure it out. Okay, so anyone else? 35D. All right, so 35D. Okay, is that it? All right, so let me start with this. Okay, so Enrico Fermi. That's good. That's good. That's good. All right, so 35. Okay, so let me sort of put this on this side here. I go. This a little bit smaller here. Okay, cannot make it smaller. Okay, so 35. No, wrong text. Sorry. 35. Yeah, I need oil. Okay, 35E. That was who asked me 35E? I think Max. Okay, Max, you're given all the resistance here. Did you figure out the overall resistance, Max?
I think.
Oh, you have sound now.
Oh yeah, because my mom is no longer calling
Oh.
today.
Okay.
So I wanted to know like how to like do it because you have like parallels within parallels.
Actually, it's all parallel. So so you have something like this here, right? Wow. Okay, so this is what is shown here, right? Where you have like R5, so what is that? So this is R2, R3, R4, whoops, R5. Actually, Max, all of these here, they're all in parallel. This is the same as, so once again here, if you follow the current comes in, splits here, splits here, goes through each device without going through any other device, right? And we'll come back here, and this one here, go here, go through each device without going through any other device whatsoever, right? And all the current will join after. So this is the same arrangement as this. This is exactly the same arrangement. All right, so exactly the same arrangement. All right, so yeah, Max. So if you actually, if you collapse this using the formula, you collapse this, you're gonna have like two more in parallel, and then you collapse them. It's exactly the same equation as using the parallel equation for all four of them. You're gonna find the same. Okay, all right. So do you want me to do it or what, Max? I'm good. Wait. Okay. So wait. Will it be the same? Yeah, like whatever the result is. So if you find, whoops, if you find like R3, 4, 5, right, which is R or R2 plus 1 over R3 plus 1 over R4 plus 1 over R5. So what do we have here? We have 1 over 1 ohm plus 1 over 50 ohm plus 1 over 10 ohm plus 1 over 1. All right, so 1 over 1. So the common factor here is 30. So you get 30 plus 2 plus 3 plus 30. Wow. So that gives you like 65 over 30 ohm. So you can divide by 5 here. So you get 6 divided by 5. What is it? 13? Is that it? 13, I think. So 2, 3, 4, 5. So if you do this, you get this. Is that okay, Max? Will it be this? Yeah, it will be the same. Yeah, it will be the same. So there may be like it'll be exactly the same. Yeah, Madav.
Sir, I did it the other way where you added up, like I collapsed the tube 2 and 3 together into a series resistor, and then 4 and 5 into a
Okay,
single.
you collapse 2 and 3 into a series resistor. You mean a single resistor?
Yeah. And
All
then
right, let's do that. Yeah.
and then I took that and
Yeah.
and
You didn't get
then
the same answer?
no, because
Hold on. So let's do this here. All right. So what do you get? You get 16 over this. So we get 2, 3. So we get R2, 3 is equal to 15 over 16. All right, so that's the first one here. The second one, so R4, 5. So it's 1 over 10 ohm plus 1 over 1. All right, so that gives you like 10. It gives you 1 plus 10. So 11 over 10. All right, and then that gives you like, this gives you like 10. Huh. It seems strange here. Well, let's see here. So let's see here if it does work out. And then, so now you're left with this. So R2, 3, and this R4, 5. And then, so if you replace this, R2, 3, 4, 5. So 1 over R2, 3 plus 1 over R4, 5. And what do you get here? So 1 over R2, 3 was 16, 16 divided by 15 ohm. 1 over this was plus 11 over 10, this. Whoops. And so once again, you have 30. So 32 plus 33. Is that it so far?
yeah, it ends up being the same. Sorry.
Yeah, thank you. All right. So yeah. So Max, are you good for this? You want me to go over it again or what? Yes, sir. Okay. So 35D. So 35D. So let's see here. 35D. All right. So let's see here. So, ouch. Yeah, in the textbook, like the red arrows, yeah, shows the electron flow, not the current. But all right. So what do we have here? So we have this. So R1, and then you have that. R2, R3, R4, and then back. All right. Okay, so let's do a little table here. So, all right, so we have V, R, I, so T, 1, 2, 3, 4. Okay, so let's see what we have. We have it's 3 amp here. We have it's 25. We have R3, which is 5 ohm. We have R4, which is 15 ohm. We have R2, which is 10. And that's it. So you have to find everything else. Yep. Okay. So first of all, like, who asked this? Jason? Justin? Okay, so the first thing here is that whenever you have all the resistance, your first instinct here would be to find the overall resistance. All right. So you can see here that R3 and R4 are in series, right? So if I combine them, R3, 4. Let's go R3 plus R4, right? So exactly, so they're in series. The current that goes through R3 is the same as the one that goes through R4. So R3 is 5 plus 4 plus 15, so 20 ohm. All right. So now what you have, you're going to have like something like this. So R1. So now you've collapsed these two, R3, 4, and here R2. All right. All right. Let me see. Good. So you can see here that these two are in parallel. So let's do parallel here. So R2, 3, 4 is equal to R2, 1 over R2 plus 1 over R3, 4. Sorry. So you get 1 over R2 is 10 ohm plus 1 over 20 ohm. So 23, 1 over R2, 3, 4. So R2, 3, 4, you inverse this, becomes this. All right, good. Now what you when you end up here, you end up with R1 and R2, 3, 4. So they are in series. So let's do it here in series. So RT is going to be equal R1 plus R2, 3, 4. And then that's going to give us R1 is 25. So 25, whoops, 25 ohm plus 20 over 3 ohm. So 3, so 75 plus 20. And that gives you 95 over 3. So that's the total resistance. 1580. I don't think you can simplify this, if I'm not mistaken. The textbook also showed us a way. Yeah, okay, hold on a second, okay, Madav, let me sort of finish this. So from this, you're given the current that goes through I1, right? So you're given the current that goes through I1. It's a little, come on. All right, so the current that goes through I1 is the same as the one that goes through through the source. So you already know that the source is going to be like 3. R2, the overall resistance is 95 over 3. So you can find the voltage by multiplying these two. And so that gives you here, your voltage is 95, all right? So you found your overall voltage here, okay? Now, what else can you do? Well, if you go here, the current that comes in, and okay, this is what I'm going to do this, Madav, in a second here. So you can see here that if you apply like the Kirchhoff current law, the current that comes in will be equal to the current that comes out, right? So it's this, all right? Well, no, it's not going to help you. No, sorry. Since you have like 25 times 3, you can find the voltage across R1. So that's going to be like 75. Now we're going to sort of find the voltage across R2, by doing a Kirchhoff voltage law across this loop, right? So going like this. So what you get here, you get that V1. So the gain here through the source is equal to the loss, VT here is equal to loss through R1 plus the loss through R2. So V2 here is equal to VT minus V1. So VT was 95 volts minus 75 volts. So you can find it's 20 volts, all right? So now you know that the voltage across R2 is 20 volts. If I go too fast, like Justin, let me know. Okay, so now that you have like the voltage across V2 and you know the resistance, you can use Ohm's law. So it's going to be like 20 divided by 10. So I'll give you like 2 amps. And now you have, so since you have like 3 amps coming in and you have 2 amps, right? So you can find the current that goes through this one, that goes through like R3 and R4. And of course, it's going to be 1 amp, right? And this is going to be 1 amp too, because they're in series. So you add them up. So 5 plus, that's it. Is that okay? Is that okay, Justin? Justin, yes, okay. Okay, so Madhav say like there's something about ratios. Okay, so I would prefer you to use like, okay, so ratios is like this, guys. So let's say here you have a parallel system here. And this is R1, this is R2. And of course, here you have like I1 and I2. Whoops. Yeah. So I2. Okay, so remember here, like when things are in parallel, they have the same voltage. That's the definition of being in parallel. So you have like V2 is equal to V1. Now this one here gives you like R2 I2 is equal to R1 I1, right? Now if you make them, if you collect the current and the resistance on both sides here, so by using like a crisscross, like if I put this here and I put this here, so what you're gonna get here, you're gonna get this. Yeah, whoops. Okay, so let me put like, yeah, let me put this in this way. So if I bring the I1 on this side and I put the R2 on the other side, this is what I get. Is that okay, Madhav? So this is where it comes from, the ratio things. Is that okay? Yeah. Yeah. So if this one here is twice as, has a resistance twice as much as R2, then you're going to have like half as much current going through R1 that you have through I2. Okay. It's all based on the fact that they are parallel. Okay. All right. So any other questions? Okay. All right. So today, I'm just going to talk about, what am I going to talk about? Okay, just a couple of things here. The power, I'm not going to put like a new title for this, but remember here the power, well, okay, so power for electrical device. All right, so remember here, this equation here is true for sources or for loads. Okay, so for sources and loads. Now, for loads, we also have this relationship here, right? Which is Ohm's law. So if we take this and put this back here, what you're going to get 2 more equations here. So if you isolate for V, and then, sorry, if you substitute Ri into here, what you're going to get, this. Okay. So this is another formula for loads. Also, if you isolate for I instead, right? So what you're going to get, this. Right? So if you isolate for I from the Ohm's law, it's V over R, and then you put this, and this is what you get.
Wait, why? How come R times I equals to R squared?
Sorry. Thank you. So RI square. There was something in the back of my mind. I said, that sounds suspicious here. Thank you. Thank you. Yeah, so these are additional equations that you can use for loads. Okay, for loads. Now, it's very important here for you to understand that resistance or resistivity is a property of the electrical device, okay? Not power, not voltage, not current. I repeat this. Resistance or resistivity, right? If you neglect the effect due to length and area of a wire, but anyway, so resistance is I already mentioned this, but is a physical property of a given device. Okay, so this is very important here, right? Does it depend on temperature? Yes, it does depend on temperature, but most devices here, the dependence on temperature is not very crucial, unless you have a device that measures temperatures by virtue of resistance. So yes, it does. But anyway, so resistance is a physical property of the device. Okay, so voltage is not a physical property of a device. You can set like any voltage across your source until a certain amount, so it doesn't blow up. Current also, you can vary the amount of current going through. Forest again. What else do you have? You have also, so voltage, current, and so on. So the resistance will stay. Okay. All right. So now let's go. I'll give you like the this is from this is my grade 9. All right. So teaching you the same thing. So why not? So I don't need like to. All right. So electric energy usage. Energy usage. Okay. So electrical companies, they charge you by the amount of electric energy you use. They don't charge you by how much electricity how much electricity you use up. But when I want to emphasize here, they don't give you the current, right? Your wires already supply the electrons, right? So it's like the water company does not provide you with water. You already have water in your pipes, so the water company will just make sure that there's a difference in pressure so that when you open the faucet, water flows down. So remember here, like power is the rate at which energy is transformed, like used up, generated, blah 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 blah, with respect to time. So if I put this in terms of energy, so the energy consumed, like generated, dissipated, so on, is equal to the power times the time. So joule is also a unit of watt second. Now, if you look at electricity bills, I know that you don't have a concern about this because it's your parents who pay for you. But when you're on your own and you get your electricity bills, as I said, they charge you by the amount of electrical energy you used up. Now, they don't give you the amount of electrical energy used up in joule. They could, but it would be like a super long number. So what they do instead here is they use the unit of kilowatt hour. All right, so kilowatt hour. Let me sort of stop sharing here because it's kind of laggy here. I'll share this again. Share this again here. So if you look on your bill, It's not given in joule, it's given in kilowatt hour. All right. Let me see, look at mine. Toronto Hydro. So according to, for a month period, from roughly April, roughly mid-April to mid-May. Well, no, it's not mid. No, we're not mid-May. Where is it? Tell me for which. Oh, there we go. So from mid-March to mid-April, I used up like 412 kilowatt hour. Right, this is how much electrical energy my house used up. Okay, so let's do a very simple problem here. Let's say you have, so any device has a power rating for the most part. So I don't have like something here, but, well, I have my Batman. Nice, huh? Okay, so let me sort of check here. So somewhere there should be a power rating. Although this one, it doesn't work with electrical plug, it's battery operated, so it'll be like a little different. Oh, Batman does not have the power rating on it, probably because it has an infinite power. And he's Batman, right? After all. Okay, so all devices here that you plugged in have a power rating. So here, like, let's say here that your toaster is rated as 1200 watt. So a 1200 watt toaster is used, yes, Max, is used every day for 5 minutes. Yes.
So for the energy, when you have kilowatts per hour times hour, it would be kilojoules, right?
No, kilowatt hour does not give you kilojoule exactly.
Oh, so it's still joules?
No, it's not exact. No, just, can you wait? Okay. All right. So a 1200 watt toaster is used every day for 5 minutes. So find how much electrical energy is consumed by that toaster in a month. So you want to know like how much electrical energy is used up. Not in joule. If you want it in joule, all right, mister, if you want it in joule, so you would take this, right? But you would convert 5 minutes into seconds. And I will give you like 300 seconds. And then 300 times 1200 watts will give you the consumption in joule, right? But since the electrical bill is given in kilowatt hour, you have to convert in kilowatt hour. So the first thing you want to do is you want to change watt into kilowatt. All right, so that's the first thing you want to do. So 1200 watts into kilowatt is, of course, 1.2 kilowatt. The next thing, since you want it in hours, so you have to convert this into hour. Of course, you're not going to convert 5 minutes to hours. What you're going to do here, since I want in a month, you're going to sort of find out how many minutes this toaster is being used in a month, the monthly, and then you convert it into hours. So in order to keep it like simple here, we're going to assume that 1 month is 30 days. All right, so 1 month is 30 days. And okay, so how much we use this per day? How much time? We use this like 5 minutes. So let's find the monthly time. So 5 minutes per day is equal to 1 hour. 1 hour in 60 minutes. So you see like you conversion here times, of course, 30 days in a month. All right. Of course, that's going to give us this. So in a month, this toaster is being used for 2.5 hours total per month. Okay, so that's a monthly time. Should have done this in grade 9 anyway. I know that my guys did it in grade 9. I don't know if Mr. Chibano did it, but Max, did Ms. Chibano teach you that? Yeah,
The
Max?
unit conversions, like she didn't show like as many steps as you did, I don't think.
Yeah, okay. All right. Now that you have like this, then you use the formula, right? So the energy consumed is equal to the power rating in kilowatt times the time in a month. Then you do this, and this is how much kilowatt hour this toaster is using up in a month if you use it 5 minutes every day. All right, so when do I have to pay this bill? May 17th. Yeah, Sunday. They shouldn't allow like deadline on Sunday. That's pretty bad. Okay. So now very often you want to know like how much it does cost you, all this electrical energy. So what you need here is you need what is called a rate. All right, so a rate, I'm going to tell you here, of course, in Toronto and probably in York too, rates depends on the time of day, but since COVID-19, I think it's all the same rate all throughout. So it's off peak, and the off peak here is on mine is 10.1 cents per kilowatt hour. So that's an off peak. And then when it's on peak, the highest is 20.8 cents per kilowatt hour. All right. So if you want to find the cost, so the rate is, of course, like this number I gave you, like 10.1 cents per kilowatt hour. This is called the rate. So if you want a cost, you just use the energy used in kilowatt hour times the rate. So let's say like how much, find how much it costs per month to use a toaster. If the rate is 15 cents per kilowatt hour. Well, you just use this formula here and bingo. All right. So the cost, the monthly cost will be equal to the amount of energy used up per month times the rate, 50 cents per kilowatt hour. And then you get a rate. So you get how much it costs you to run this toaster 5 minutes every day for a month. So it costs you like 45 cents per month. Now you might say, well, that's pretty cheap. Yeah, but don't forget that you're not using only a toaster. And there are some devices here that are on all the time, like your fridge, right? So in a month, it adds up, all those devices. Bill there, behind my Lego Batman. There we go. Okay, questions? You good? Okay, so that's it. So there's a couple of questions here. Shouldn't take you like too long to do that today. Yep, and yeah, then tomorrow I'm going to teach you something. It's not in the textbook, but it's part of the IB curriculum. And then we'll be done with the electricity part. Again, Forrest, why does he always? And then after we'll start the magnetisms. Yes, Max.
So tomorrow is the last lesson for electricity, right?
Yeah.
And then is magnetism the last unit, or do we have another unit after that?
No, that's it. Well, it's not. It's the same unit. It's electromagnetic electromagnetism. So, yeah. So
Okay. Is it like a long unit? Because we still have a lot of time left in this school year.
yeah,
Okay.
yeah, we'll be done like earlier.
All right.
Yeah, Madav.
Should we expect a bunch of quizzes or assignments at the end of the school year?
No, I'm not giving you quizzes. You're gonna have a CPT. Yeah, when we're done everything, I'll tell you what the CPT is. Okay. Yeah. Any questions? Yup. More chat. Who's chatting? I don't think, Ernest. I honestly don't think we'll go back to school. If only to drop off your textbooks. And if we come back, no, there won't be any quizzes, no tests. It'll be the CPT. So, right. Hopefully by that time you'll be done. You might be done by May the 31st anyway. So everything, if you're good, you'll be done by May 31st. Okay, so any other questions? Yeah, Max?
Oh, yes, sir. So like how so like blah, blah, sorry, I cannot formulate words. So like for ISU, like do you have any like updates on like how that'll like work out?
The speed ISU?
Yeah.
Yeah, I'll put it like in the same bin as I would like if you had if you were in class, right? So
Okay.
it goes into application, I think, and communication.
Okay, but is there going to be like some like online test that we have to do
No.
for the ISU?
No,
Oh, okay.
no.
So it's just like handing it in for completion.
Yep.
Okay.
Yeah.
Let's go.
So it's already given on the. I mean, I did not put like this in D2L, but I'll do this a little bit like later. But I think the deadline is 22nd, I think, of May. You have to submit this. I'm using the browser app right now. Yeah, that worked for me too. So in that case, it wouldn't be, yeah, okay, that's a long time ago. Sorry. I will go back. No. All right, guys. So that's it. So I'll see you like tomorrow at 10:30. And please do not attempt to go in my in the Zoom, right? Like before I send you an invitation, guys. And then I will sort of try to change the password. I didn't know. I'll check, like I'll see. I'll find a way to change the password. It's a bit more secure. All right, guys. So I'll see you tomorrow, and take care. Bye.
Bye, sir.
Bye.